Hi everyone, and welcome to Activity 16, Part 1. In today's lesson, we are going to talk about determining what kind of figure we are going to have specifically based on given information. And you're going to want the supplemental notes handout or a notebook to take notes in, a pencil, and possibly a highlighter. So on this handout here, we see a bunch of different properties, and then we see some of the figures we've talked about, particularly the parallelogram family. And we want to put an X in the box that relates to each of these shapes, okay? So which of the following have opposite sides congruent? Well, for the parallelogram, the opposite sides are congruent, which means for the rectangle, the rhombus, and the square, that will also be true. The second one wants which figure has opposite angles congruent. Well, again, that's true for the parallelogram, so it's true for the other three figures as well, because if it's true for the parallelogram, it's true for the members of that family. Which figures have diagonals that bisect each other? Well, that's also our parallelogram, and thus the rectangle, the rhombus, and the square. And now for part D, we start looking at some specific properties that are a little bit different, because all angles are 90 degrees, not in a parallelogram necessarily, but for sure in a rectangle and a square. All sides are congruent, not necessarily in a parallelogram, but in a rhombus and a square specifically. That is true. The diagonals are congruent, not necessarily in a parallelogram, but in a rectangle and a square. And then last but not least, the diagonals are perpendicular, not necessarily in a parallelogram, but in a rhombus and a square. Okay? So now using that information, we want to decide what would be the most descriptive name out of these that we could give the following figures with this information. Okay, so number one is a parallelogram with at least one right angle. Well, if it's a parallelogram and has at least one right angle, that means based on the information of a parallelogram, we know the opposite angles are congruent, same side interior angles are supplementary. That means if it's got at least one right angle, it's going to have to be a rectangle. Now, a parallelogram that is both a rectangle and a rhombus, we know is special to our squares, because squares have both involved in them. Now, a quadrilateral with opposite angles that are congruent, it means that we have a four-sided figure, and if we know the opposite angles are congruent, the most descriptive thing we can say about this is that it is a parallelogram, right? Parallelograms are going to have opposite angles congruent, but we don't know enough extra information to say if it's specifically a rectangle, a square, or a rhombus, okay? Now, the next one says we have a parallelogram with diagonals congruent. When we talk about diagonals being congruent, if we go back up to the chart, diagonals are congruent in a rectangle and a square. Well, they don't tell us enough information to say it's specifically a square, so as descriptive as this is going to get is a rectangle. A parallelogram whose diagonals are perpendicular, again, if we look back up here, diagonals are perpendicular in a rhombus and a square, but we don't, again, have enough information to say beyond just rhombus that this is also a square, because we don't have enough information about properties to say specifically square. Now, a parallelogram whose diagonals create 45-degree angles is going to be specific to a square, and the reason being, it is going to not only have to be a right angle here, but it's also going to have to bisect and to be 45 each, right? These baby angles. So that's going to specifically be for a square because it's doing both two things, one property of a rectangle, one property of a rhombus, okay? A parallelogram with four congruent sides, well, if it's going to have four congruent sides, it has to be at least a rhombus. We don't have enough information to say if it's anything beyond that. A quadrilateral whose diagonals bisect each other. Well, bisecting diagonals is a property of a parallelogram, thus all the rest of them. So without any extra information, all we can say is this is a parallelogram. And then last but not least, a quadrilateral whose opposite sides are congruent is going to be descriptive of, at best, a parallelogram, because again, we don't have enough information to say if it's specifically beyond this a rectangle, a rhombus, or a square. We just know that the opposite sides are congruent. Okay, so you have to have an extra piece of information to say a step beyond. Otherwise, you have to go with the least descriptive figure so that you encompass everything if there's not extra information given. Now, we also want to be able to decide looking at this visually as well. So we see these figures here. And just because it looks like the shape of a square, you're not going to necessarily call all of these squares. You're going to use the given information, like we did with the word phrasing, to make the most descriptive. So in this case, what the figure has marked in part A is that opposite sides are congruent. So if opposite sides are congruent, we know that, again, we don't have enough information to say anything more specific than this is a parallelogram. In the second one, hopefully you're noticing that these diagonals are perpendicular because they're creating this right angle. We also notice that the diagonals are bisecting, right? Because we have two congruent pieces here and here, and then the other one is congruent in its own way. So because the diagonals are being bisected and we have perpendicular diagonals, those perpendicular diagonals are showing us that these are going to be a rhombus. Okay, we don't have enough information to say it's specifically a square, but we do know enough to say it's a rhombus. In the third example here, we have not only opposite sides congruent, similar to part A, but we also have this 90-degree angle. So what this is showing us is because we have at least one right angle, this is going to have to be a rectangle. Again, do not have enough information to say it's specifically a square. Letter D, we do not have enough information to say anything about this being a parallelogram because we only have one side congruent and we only have one side parallel. So this could be a parallelogram, but without any extra information, it could also have been a trapezoid. So what we would say is, since this wasn't descriptive enough, we would just say that this is a quadrilateral, a four-sided figure, because we don't have enough information to prove it is a parallelogram. In the next examples, we have all four pieces of our diagonals congruent, which means that the two diagonals overall are congruent, right? So because those pieces are congruent, the diagonals are congruent, which means this is going to be most descriptively a rectangle because we do not have enough extra information to say that this is a square. All right, on the next one, not only are the diagonals congruent, like in letter E, but we also have perpendicular diagonals, like letter B. So because the diagonals are congruent and they're perpendicular, then we know because it's got properties of both a rhombus and a rectangle, this could be specifically called a square. Now, in the next example, we have the perpendicular diagonals and we have four congruent sides, right? Because we have all pieces marked here congruent. So those are both properties of a rhombus, the four congruent sides and the perpendicular diagonals. We do not have any extra information, though, to say that this could be a square. Letter H, we have two pairs of congruent angles, but they're not opposite. So because they're not opposite, we would say that this is just a quadrilateral because, again, this could be a trapezoid because we don't have enough information to know if they're all congruent to each other. And then last but not least on here, because we have two sides congruent and we have these opposite, or all the angles congruent, we know because all the angles are congruent, they all would have to be 90 degrees. So that's a property of a rectangle. And then the consecutive sides being congruent kind of end up meaning all four sides are congruent. So it's got properties of a rectangle and a rhombus, which means it's going to overall be a square. Now, the last piece of today is identifying, are these statements true or false? And if they are false, we're going to explain why. So the first one, a square is a parallelogram. Well, we know that is a true statement, right? All squares are parallelograms. Now, are all parallelograms a rectangle like in letter B? That is false. Okay, a parallelogram is only sometimes a rectangle because sometimes it might just be a parallelogram, maybe it's a rhombus. We don't know, so only sometimes. Is a square a rectangle? That is always true. It always falls under the rectangle category and has all of its properties. But a rhombus is a rectangle would be false because only sometimes is that rhombus a square. And if it's a square, it's both. A rhombus is a rectangle, but overall, it's not going to always be a square. Sometimes it might just be a rhombus, in which case it's not going to be a rectangle. Last two examples, a square is a trapezoid. That is false, right? Because they are never the same, because on our family tree, they never cross over. And then last but not least, a rectangle is a parallelogram. That is true. Always, it has all of its properties as well. Okay. We will work more in part 2 with identifying what is the most descriptive name of our shape. See you guys in class.